Okay guys, we got some additional Ampacity questions to go through here. You have this in your handout, but if you don't, if you're just looking at this from the video, then write down these values and see if you can finish off the chart, and then we'll bring up the answers. So for this guy, we're going to look at tables 1 through 4 with our base Ampacity based on whether it is copper or aluminum, or whether it's conduit, cable, or free air. So table 1 through 4 for these guys. Then we're going to look at number of conductors. If it's above 3, we're going to make use of table 5C and derate this value down to a reduced ampacity. And then after that, we're going to look at table 5A. And if the ambient temperature is greater than 30, we're going to make use of table 5A to take this current and then come to a final ampacity based off of these reduction values. Okay, so let's make this a little bit bigger so we can see what we're doing. And we'll go through each of these examples here. So let's start off with the number 4 copper RW75s that are run in conduit. So for those guys, if we have copper run in conduit, we're going to go to table 2. I've got that open beside here. So table 2, number 4s. So again, let's make this just a touch bigger. Hang on 2 seconds. Okay, so we're looking at number 4s here. Which column we're in? The 75-degree column there. So for those guys, it looks like we've got 85 amps, right? So 75-degree column, number 4, I got 85 amps as my base ampacity there. Okay, once we've got that guy, then we can go to table 5C. We've got 8 conductors, right? So 8 conductors would be in the 7 to 24. So we've got a multiplier of 0.7 there. So we've got 85 amps. We're going to multiply that by 0.7. And if I take 85 and multiply by 0.7, I'm getting 59.5 amps because of the fact that I've got 8 conductors in that conduit there. Okay, next thing we're doing is we're going to table 5A. So let's scroll up to 5A. And we've got 2 different temperature ratings. So we've got 75 degrees for the insulation rating, which is right here. Then we've got 45 degrees for our ambient air temperature. And where those two intersect, I can see that the multiplier is going to be 0.82. So I'm going to take the 59.5 amps that I had above, multiply that by 0.82, and 59.5 times 0.82 gives me 48.79 amps. Okay, so that's my maximum ampacity for my number 4 copper RW75s that are running conduit. 8 conductors in the conduit derated us down to 59.5 amps. And then because we have an ambient temperature above 30 degrees, we have to derate to 48.79 amps for each of those conductors. Okay, let's take a look at the next guy, guys. We've got number 12 copper. They're also run in conduit. So we're back to table 2. So table 2, we're in the 60-degree column because we're looking at TW, and TW is good for 60 degrees. So number 12s in the 60-degree column are good for 20 amps. So we'll put in table 2. Okay, so base ampacity there is 20 amps. We got 9 conductors there, so we got to go to table 5C. 9 conductors is again going to derate by 70%. So we're going to have the 20 amps, and we'll multiply that 0.7. And 20 amps times 0.7 gives me 14 amps. Okay, not only do we have 9 conductors in the pipe, but we have an ambient temperature of 55 degrees. So we got to go to table 5A. Table 5A, we're in the 60-degree column right here. Our ambient temperature is 55. So that's going to give us a multiplier of 0.41. So then we got 14 amps times 41%. And if I do that on my calculator, I'm getting 5.74 amps. So we went from a base ampacity of 20 amps for the number 12s, then down to 14 amps because there was 9 conductors in the pipe. And then because it's quite hot at 55 degrees, then we have to multiply by 0.41, giving us only 5.74 amps on each of those number 12s. Okay, hopefully you're getting the same answers here, guys. Next one, number 3, copper in conduit. So we're in table 2. Okay, so let's go back to table 2. We're in the 75-degree column. We got number 3s, so that's going to be good for 100 amps, guys. You can see that right there. Okay, there are 5 conductors in the pipe, so we got to go to 5C. 5 conductors is going to give us 80%. Okay, so we got 100 amps times 0.8. That gives us 80 amps maximum ampacity so far. Okay, next thing we can see is that we're at 40 degrees ambient temperature. So we're now going to go to table 5A. So 5A, starting off in the 75-degree column, right, because we're TW75. Then looking at the left-hand side of 40, so we're 75 and 40 intersect. Let's see at a multiplier of 0.88. So I'm going to have the 80 amps multiplied by 0.88. And what's that going to be? It gives me 70.4 amps, guys. Okay, let's look at the next one, guys. Next one is number 6, aluminum, TW. Again, TW has a rating of 60 degrees. Okay, so aluminum in conduit is going to be table 4, right? So we've got aluminum in Raceway, so that's table 4, guys. What do we got? Number 6s, and we're in the 60-degree column there. So number 6s in the table 4 looks like they're good for 40 amps. Okay, we can see here that there's 3 of those guys in the conduit, so we're going to take that 40 amps and keep that at 100%. So we're still at 40 amps there. And looks like we've got ambient air temperature not greater than 30 degrees. So again, our 40 amps is still going to stay at 100%. And so our maximum ampacity for the number 6 aluminums, TWs, run in conduit with 3 conductors is going to be 40 amps based off of table 4. Okay, let's take a look at the next one. Again, aluminum in conduit. We got number 2. We got 2 aughts in the 75-degree column because we get TW75. So let's write our table down first, guys. Table 4. Okay, 75-degree column for 2 aughts. Looks like it's 135 amps, guys. Okay, looking below, there's 4 of those guys in the conduit. So we're going to have to go to 5A for our multiplier. So we'll write down our 135 amps. Let's go to 5C to look at our multiplier there. So 4 conductors is going to give us 80%, right? So that's this multiplier right here. Okay, if I take 135 and multiply that by 0.8, that gives me 108 amps. Okay, let's take that value, let's put that down here. And we'll go to 5A because we're above 30 degrees. We're at 45 degrees here. So 5A, we're in the 75-degree column here. We're going to an ambient temperature of 45, so that'll be a multiplier of 0.82. Okay, so if I take the 108 and then multiply it by 0.82, it's going to give me a value of 88.56 amps for my maximum ampacity for the 2-aught aluminum TW75s that are run in conduit. 4 of those guys reduced our ampacity from 135 down to 108. And then the 45-degree ambient temperature then reduces down to only 88.56 for each of those conductors. Okay, let's take a look at the last 2 here, guys. So we got free air. We're going to be in different tables here, though, because one is copper and one is aluminum. So let's start off with the first one for copper being free air, right? So ampacity of single copper conductors run in free air. We're in the 90-degree column there. We're looking at 4 aughts. So 4 aughts in the 90-degree column is going to give us 405 amps. So we're in table 1. And we had 405 amps as our base ampacity. Those are single conductors, so that 405 amps is going to be taken at 100%. So we're still at 405 amps, and then ambient air temperature is at 30 degrees, so the 405 still stays at 100%. And so maximum ampacity for the free air copper conductors, R90s, that are sized at 4-aught are going to be good for 405 amps there. Okay, let's do the last one, guys. So what do we got? We got 3-aught aluminum in free air. So that's going to take us to table 3, right? Aluminum conductors in free air. We're in the 90-degree column there. And the size of conductor is 3-aught. So 90-degree column and 3-aught looks like it's good for 270 amps. So we'll put in here table 3. And we got a base ampacity of 270 amps. It's only a single conductor, so that 270 is going to remain at 100%. So we don't have to make use of 5C. Okay, but we do have quite high ambient temperature at 60 degrees. So be careful with this one. I made a mistake on this one numerous times. Let's look at the multiplier there. We're going to go to 5A now. Starting off in the 90-degree column, right, because we're RW90. And then we're going to 60 degrees. So 90-degree column to 60 looks like our multiplier is going to be 0.71. Okay, so we got 270, and we'll multiply that by 0.71, or 71%. That gives us 191.7 for our maximum ampacity for those 3-aught aluminum RW90s that are run in free air in an ambient temperature of 60 degrees. Okay, so hopefully everybody's got the same answers as I just showed there. Let's scroll down and I'll have a clearer version of those answers there. And I'm going to bring up one more chart, guys. But hopefully so far you're getting the understanding of tables 1 through 4, tables 5C, and then table 5A. Okay, so we'll start off with table 2 again, guys. So if you don't have a copy of this, it should be in your handout. But if you don't have a copy, then you can copy these values down. Find each of the appropriate values for tables 1 through 4, then see if you have to derate with table 5C, and then see if you have to derate with table 5A. Once you finish those guys, then restart the video, and we'll go through each of these individual examples. Let's start off with the first guy, number 10, copper in conduit. So that guy is going to be table 2. Okay, if we take a look there, we're at TW, so TW is good for 60 degrees. So 60-degree column there, we're at number 10s. They're good for 30 amps. Okay, then we got 7 conductors. So we got to go to table 5C. Let's see what the duration there for 7. Looks like we're at 70%. So we got our 30 amps times 0.7. And 70% of 30 amps gives me 21 amps. Okay, then we're at 40 degrees, so we got to go to table 5A. So let's look at 5A now. Which column are we in? We're in the 60-degree column, and then we're gonna, that's the top, then the left-hand side is gonna be 40 degrees. So that gives me a multiplier of 0.82. So I got 21 amps. I'm gonna take 82% of that. And if I take my 21 times 0.82, gives me 17.22 amps, guys. So max ampacity for number 10 copper TW conductors running conduit with 7 conductors in the pipe and an ambient temperature of 40 degrees would be 17.22 amps. Okay, let's take a look at the next one, guys. Number 6, copper in conduit. So we're again in table 2. We're in the 75-degree column. So if we look at 75-degree column, let's go up to table 2. Number 6s, that's good for 65 amps. Okay, but it looks like we've got 6 conductors in that conduit there, so we got to go to 5C. For 4 to 6, we got a multiplier of 80%. So we'll take our 65 amps, multiply that by 0.8, and 65 times 0.8 gives us 52 amps. And it looks like that 52 amps can stay at 100% because we're at 30 degrees or below. So we got 52 times our 100%. And so we got max ampacity of 52 amps for number 6 copper TW75s running conduit with 6 conductors in the pipe. Okay, hopefully you came to the same conclusion. Next guy, what do we got? We got number 8 aluminum, and it's in flexible conduit. Okay, so that guy is going to be in table 4, right? So we've got aluminum conductors in a raceway. We're in the 75-degree column here for number 8, so 75 degrees, and we're looking at number 8. That's good for 40 amps. Okay, so we're in table 4. We got 40 amps. Beauty. And let's see, we got 4 conductors in the pipe there, so we got to go to 5C. There are 4, so that's 80% as our multiplier. So we'll take our 40 amps, multiply that by 0.8, and that gives us 32 amps. Beauty. Okay, now we got to go to table 5A because we got smoking 49 degrees Celsius there. So let's go to 5A. And we're in the 75-degree column there. Ambient temperature is 49. So that's going to have to be in the 50-degree column, right? Because we're above 45 there. So that's a multiplier of 0.75. So we got 32 amps. Multiply that by 0.75. And that gives me a maximum capacity of 24 amps for the aluminum number 8 TW75 run in flexible conduit with 4 conductors in the pipe and an ambient temperature of 49 degrees Celsius. Okay, let's do the next one, guys. We are back to copper and conduit, so we're back to table 2. Okay, we're in the 60-degree column because we're using TW. So, and our size of conductor is number 14. So those guys are good for obviously 15 amps. So we're back at table 2 for copper in a raceway, and we're good for 15 amps. There is a disgusting number of conductors in there. We got 27 conductors in there, so we got to go to table 5C, and that would be 60% of the ampacity that we found earlier. So we've got 15 amps. And multiply that by 60%, and 60% of 15 amps gives me 9 amps. Okay. In addition to that, we have an ambient air temperature greater than 30 degrees, so we're going to have to go to table 5A. Okay, starting off in the 60-degree column, and then going to 45 for ambient air temperature. Looks like our multiplier is going to be 0.71. So we're going to take our 9 amps that we had, multiply by 0.71, and 9 times 0.71 gives me 6.39 amps. So they were good for 15 amps, but then once we had crowded the entire conduit with 27 conductors and an ambient temperature of 45 degrees, we're now down to 6.39 amps for those number 14 copper TWs running conduit. Okay, next one, guys. We got 1/0 aluminum free air. So what table is that going to be? That's going to be table 3. We're in the 90-degree column there for RW90. Okay, we got 1/0, so 90-degree column. Looks like those guys are good for 205 amps. So we're table 3 because it's aluminum and then 3 air. And those are good for 205 amps at the moment. We have 1 conductor there, so we're going to have 100% of that value. So we're still at 205, but we've got an ambient air temperature of 60 degrees. If we go to table 5A, we're going to start off in the 90-degree column here. Ambient air temperature is going to be 60, so the multiplier is going to be 0.71. So we're going to take our 205 amps. We're going to multiply that by 0.71. 205 times 0.71 gives us 145.55. Okay, so number 1 aluminum conductors RW90 run in free air. in an ambient air temperature of 60 degrees, you're going to have a maximum ampacity of 145.55 amps. Okay, let's take a look at the next guy. Next guy is free air as well, but they're copper, right? So we got to go to table 1 for that. Yeah, copper and free air. Okay, this is mineral insulated cable. There's a note at the base here for mineral insulated cable here. Ratings are based on the use of 90 degrees insulation on the emerging conductors, and for steeling, where deviation has been found allowed in accordance with the rule 2.030, mineral insulated cable may be used at a higher temperature without a decrease in the allowable ampacity, provided the insulation, sealing material, and any jacketing material are suitable for the higher temperature. Okay, so let's take that at 90 degrees, guys. And so size of conductor is number 4. Okay, we're free air there. So we're in table 1. And if we look in the 90 degree column at number 4s, those guys are good for 140 amps. Okay, there's 3 of those conductors run in free air. So we're going to remain at 140 amps. And they also have ambient temperature below 30. So then we can keep that 140 again at 100%. And so the number 4 copper mineral insulated cables that we have run in free air are each going to be good for 140 amps as our maximum ampacity. Okay, guys, last one. Last one is copper in a cable. So copper in a cable is going to be table 2. Okay, we're in the 90 degree column because we're RW90. And we're looking for 250 kc mil or 250 MCM. So those guys are going to be good for 290 amps. Again, we're in table 2. Okay, there's 3 conductors there. So that 290 can remain at 100%. And looks like we're finishing off with an easy one. We're at 30 degrees or below. So the 290 can then remain at 100%. And so the 250 kc mil or MCM copper conductors, RW90, that are in a cable with 3 conductors in that cable are good for a maximum ampacity of 290 amps. All right, guys, hopefully everything's worked out there. We've got a clearer picture or clear image right here for each of those guys. So hopefully you found the exact same values as I did. You got a good understanding of tables 1 through 4, got good understanding of table 5C if you have more than 3 conductors in the pipe or the cable, and then got a good understanding of how to use table 5A if the ambient air temperature is above 30 degrees. Okay, hopefully everything worked out, guys. I'll see you guys on the next video.